So we're going to be solving polynomials now, and in order to solve a polynomial, you basically want to be able to get it down to a quadratic, because once it's down to a quadratic, we have ways to solve the quadratic. You have factoring, check factoring first, you have completing the square, you have quadratic formula, you have solving by square roots possibly. We're most likely just going to check factoring first, and then if that can't, we'll go to quadratic formula unless it can be done by solving by square roots. So for this first one, I have a cubic. Well, if you notice, every term starts with or has an x, so that is a common factor. And so that's the first thing you want to be checked for. Remember, always, 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 still, always, always, always check for a common factor. So I'm going to factor an x out, and what I have left is 2x squared minus 5x minus 3. And then now I want to check to factor this, and I can use the t-chart. I have 2x times x, and what multiplies to be negative 3, negative 3, positive 1. I have negative 6x, positive 1x adds up to my middle term of negative 5x. Remember to circle diagonally. So I have x, and then x minus 3, 2x plus 1 equals 0. I'm okay with you taking some shortcuts here. Now, if you're familiar with it, to solve, remember you have to set each of them equal to 0. With the x, that's always going to be x equals 0. This becomes, I set it equals 0 and solve, so it becomes positive 3. And this one doesn't just become negative 1, but I got to subtract the 1 and then divide by the 2, so it's negative 1 over 2. And those are my solutions. For this next one, factor out the GCF. Well, I can factor out a 3 and x squared. So what's going to be left in this first one is x squared plus, not 3, but 4x, because I factored out an x squared, this just becomes x to the first, and this just becomes minus, not 6, but 2. So now I'm looking to factor this. What multiplies to be negative 2 that adds to be 4? You can't find anything. Negative 2 times 1, that's the only option. So here's the key step. Don't spend too much time trying to factor. If it can't be factored, you want to move and start doing, that's right, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 4 plus or minus 4 squared minus 4 times a is 1 times b is negative 2. All over 2 times 1. Understand I'm just doing the quadratic formula for this. My a is not 3. That's factored out in front. So let me finish this and then I'll get back to this part of it. So I have negative 4 plus or minus the square root of 16. This is going to become plus 8 all over 2. Negative 4 plus or minus the square root of 24 all over 2. That's a positive, so it is real. It's not imaginary. Negative 4 plus or minus, and when I simplify this, that's going to be 2 times the square root of 6 all over 2. And this can simplify to negative 2 plus or minus square root of 6. So I have these solutions, and remember this is 2 solutions, but I also have this out in front, and because I factored out a variable, that's going to become x equals 0. So I have negative 2 plus square root of 6, negative 2 minus square root of 6, and 0. Those are all my solutions. And here we have the sum of cubes and difference of cubes. And this is very similar to the difference of squares, where there's a pattern that happens, and you need to use this formula for this one. You can't do it any other way. You got to use the formula. You don't have to memorize it. It is a part of your reference guide on the FSA, so you will be given the formula, but you do need to know how to use it. So basically, anytime you have a binomial that's a cubic, it's going to be either the sum of cubes or difference of cubes. And each term is going to be a perfect cube. So to find the a and the b is what's key. You're going to take the cube root of each term. So a cubed is x cubed. That's what's in that spot. So what I want to do is find a, and a is going to just be x. If b cubed is 27, if I take the cube root of that, that means b is going to be equal to 3. So I have a is equal to x, b is equal to 3. From there, you're just plugging it into the right formula. Since this is the sum of cubes, I'm going to use the SOC formula. That's what I'm going to refer to this as, SOC and DOC. The sum of cubes formula, I'm going to use this one. So it's a, which is x, plus b, 3, times a squared minus, or I'm sorry, x squared minus 3x, a times b, plus b squared, well, that's going to be 9. And let me make this equation and we'll go ahead and solve it. Okay, so for these, if it's just asking you to factor it, this is the factored form, you'd be done. When we make this equation and we're solving it, let me change the directions here. And we're solving it, what's going to happen is, well, this one's going to be easy, x equals -3. If you ever use this sum of cubes or difference of cubes formula, you're going to have to use the quadratic formula for the quadratic part. Okay, it's not going to be able to be factored. So I have x equals +3 plus or minus the square root of 9 minus 4 times 1 times 9. All over 2 times 1 is 2. So I have x equals 3 plus or minus the square root of 9 minus 36 over 2. 3 plus or minus the square root of, it's going to become -27 all over 2. And now this is going to simplify into my final answer. So I'm going to put it up here with my x. X equals -3 and 3 plus or minus. If I simplify this radical, use a birthday cake factor tree, you're going to get 3. There's an I because it's a negative times the square root of 3 all over 2. And those are my solutions. So for this one, find the a and find the b. The a is going to be the cube root of 8x cubed. Well, the cube root of 8 is 2. Because the x is there, you got to have the x as well. The cube root of 1 is 1. You're not using -1. The fact that it is a minus just means that I'm going to use this difference of cubes formula. So I have a minus b instead of a plus b. So 2x minus 1. And then 2x squared. A big mistake here is people will just write 2x squared like this. But you're squaring the whole a term, okay? And that's what's key here. Plus 1 times 2x is going to become 2x plus b squared, which is 1. So 2x minus 1, when I square this term, that's going to become 4x squared plus 2x plus 1. I'm not going to solve this one just to save time. This first part would be x equals +1 divided by 2. And then you would use the quadratic formula to solve this second part. Okay, so this is another type. You can't factor out a GCF, you can't factor out an x, and I can't get it down to a quadratic right now. So the way this is, I call this a special quartic, because when it ends up being this type of quartic where it's x to the fourth, then an x squared, and then your constant, normally you will be able to actually factor it. And so if you're using the t-chart, you go ahead and do the t-chart. And for those of you that are doing other methods of factoring, you can still use your other methods of factoring for it as well. The only difference I'll show you at the end. In the t-chart, the only difference is instead of an x times x, it needs to multiply to be x to the fourth. So you have x squared and x squared. And then you have -4 and +1. -4x squared, +1x squared adds up to -3x squared. You're doing the same thing as factoring. The only thing that happens is when you factor it, it ends up having an x squared and an x squared in that first part of the parentheses, and that's it. If you're starting to get to the habit where you notice this is a 1 and these are just going to be the same, I'm okay with you without showing your work, just going what multiplies to be -4 that adds to be -3. That only works when the a is not a 1 though. And then from here you solve it. And to solve it from here, set it equals 0 and solve. You can factor this first one, but you won't always be able to factor it. If you want to factor it, but you can also just use square roots. The main part to solve by square roots though, get the x squared by itself. When you take the square root of both sides, remember you have that plus or minus, and I get plus or minus square root of 4, which is 2. You could have also factored it into x minus 2 times x plus 2, but you won't always be able to factor them. Like this second one. I can't factor that one, so I have to solve by square roots. So I do subtract 1, x squared equals -1, take the square root. And when I take the square root of -1, I take the square root of both sides, I have the plus or minus, and square root of 1 is 1, but it's a negative, so it's 1i. And so my solutions are plus or minus 2, plus or minus I. Okay, so for factor by grouping, any of these solving roots, solving solutions, finding the roots, finding the real zeros, or finding all the zeros, you first want to get everything on one side and have it equal 0. And when you put everything on one side, like I'm going to subtract the 5x, I want to put it in the correct standard form. So the 3x to the third is first, then my plus 6x squared, then minus 5x, and then minus 10. And so for factor by grouping is when you have a 4-term polynomial and I can't factor anything out. So what you do is you group them. I'm going to group these two and I'm going to group these two. Now, this is a plus. If it's a minus on this third term, include that negative inside the parentheses, but make sure you put a plus here because the two parentheses are not being multiplied, and I want to express that. But that negative sign does need to go inside that parentheses. And then now for each of these groups, I'm going to factor out their GCF. So in this one, it's 3x squared, and I'm left with 1x plus 2. And then for this one, anytime this first term is a negative, factor out that negative. So -5, and I'm left with positive x plus 2. Factor by grouping will only work if after you do that step, these two parentheses match. And then you go to 3x squared minus 5. What's outside comes to 1 parentheses, and the matching one is your other parentheses. And then to solve that, you set them each equal to 0 and solve. Well, this first one is just going to be x equals -2. For the second one, 3x squared minus 5 equals 0. I'm going to add the 5, divide by the 3, and I get x squared is equal to 5 over 3. And at this point, I take my square root. Anytime I take the square root, I have to use that plus or minus. So I have x equals plus or minus. And I'm going to rationalize the denominator because I have the square root of 5 over the square root of 3. So I'm going to rationalize it and get rid of that by multiplying by the square root of 3 to both top and bottom, numerator and denominator. And this becomes plus or minus square root of 15 all over square root of 9, which is 3. So I'm going to add that to my solution set, and there you go. Notice there are 3 solutions here. Negative 2, positive square root of 15 over 3, and negative square root of 15 over 3. Okay, so here are some U-try problems. And you're going to solve them all, but make sure you get them all in the right order first. Get everything to one side and have it equal 0, and make sure it's in standard form with the highest exponent down to the lowest exponent. Go ahead and pause it, and then I'll give you the answers after this joke. What do you get when you cross a bunch of monkeys with the orchestra? A chimphony! Chimphony! All right, here are the answers.